Welcome to this video lecture on the subject optical and microwave engineering. So in this lecture we are going to discuss about optical transmitters and receivers. Optical transmitter is a device that generates the signal sent through optical fibers. So the basic elements of the optical fiber transmitter are shown this in diagram. So where we have electronic pre-processing and driver circuit, and then the optical monitoring and light source, external modulator and attenuator, and temperature monitoring. So these are the important elements of an optical transmitter circuit. So where it converts the information signal, which is electrical signal, into optical signal. The basic elements of the optical fiber transmitter are electronic interface. So there are wires, standard electronic connection or pins energizing the transmitter. They provide power, electronic input and output optical signals. And electronic processing. In some transmitter, the input electrical signal are electronically processed to put them into suitable form to drive the light source and driver circuit. So this depends on the application requirements, data format and the light source. And next element is the optical monitor. It monitors the output of the laser and provides feedback to the driver circuit so that the output power remains stable. And temperature monitor. The characteristics of semiconductor laser changes in temperature. So the lifetime of laser decreases with increase in operating temperature, and the output power also decreases with some change in the output wavelength of the light. To keep in the operating temperature stable, the thermoelectric coolers are used in optical fiber transmitters. So these coolers control the temperature of the laser. Next is the optical modulator. So the following modulators commonly used in optical transmitters. So the electro-absorption modulator, which is small and can be driven with a reasonably small voltage swing. So it is it is a reverse biased PN junction. Next is the Mach-Zehnder modulator, which generates the highest quality optical pulses with a controlled amount of chip and high extinction ratio. So it is a terminator transmission line. So the maximum transmission distance that can be achieved in an optical communication system is determined by a combination of chromatic dispersion limit, the polarization mode dispersion limit, and the attenuation limit. Next is the system architecture. From architecture point of view, optic fiber communication can be classified into three major categories: the point-to-point links, distributed networks, local area networks. The point-to-point links comprises of one transmitter receiver system. So this is the simplest form of optical communication link, and it sets the basis for examining complex optical communication links. The important aspects to be considered are distance of transmission, the channel data rate, bit error rate. So all the parameters are associated with the characteristics of various devices employed in the point-to-point link. So when the link length extends between 20 to 100 km, losses increases along the fiber cable. So in order to compensate the losses, optical amplifier and regenerators are used over the span of the fiber cable. So a regenerator is the receiver and transmitter pair which detects incoming optical signal, recovers the bit stream electrically and again convert back into optical form by modulating the optical source. So the optical amplifier amplifies the optical bit stream without converting it to electrical form. So the spacing between the two repeater or optical amplifier is called as the repeater spacing. So this spacing depends on the bit rate. So the bit rate distance product is the measure of a system performance for point-to-point links. You can have an assessment. So first one is coherent radiation is directional because the most of the light output is coupled into optical fiber. So this is because of the isotropic distribution of narrow line with coherent radiation is directional. Second one is the finite spectral width of the optical source causes Pulse broadening. The finite spectral width causes pulse broadening due to the material dispersion on an optical fiber communication link. So this results in a limitation on the bandwidth length product. Thank you for listening.